So we're going to be doing two things in this lesson. We're going to be looking at solving rational equations and then also solving absolute value equations. So I'm going to split this into two parts. So part one will be a video on solving these rational equations. The second video, part two, will be on solving the absolute value equations. So for rational equations, here's an example where we have x divided by 2 plus 1/3 equals 5x divided by 6. What we want to do here is basically turn this into something that is not a rational equation. So we do not want to have fractions in our equation. So the way that we can do that is we can eliminate the denominators by multiplying both sides of our equation by a common denominator. That means we need to find out what is a common denominator and specifically what would be the least common denominator. For this problem, I have denominators of 2, 3, and 6, and so the least common denominator is going to be 6. Now, unlike adding and subtracting rationals, where we kind of asked ourselves, what do I need to multiply each of the current denominators by to get the LCD? We're not going to do that here. What we are going to do is we're going to take each of our fractions, so we'll start with x divided by 2, and I'm going to multiply it by the LCD of 6. And then I'm going to take my next fraction, which is that 1/3. So I have the plus 1/3 for my equation, and I'm going to multiply that by 6 as well. And then I've got equals 5x over 6, and I'm going to multiply that fraction by 6. And so you can see we are taking each of our terms and multiplying it by the LCD that we came up with, which was 6. What that's going to allow us to do is get rid of the fractions. We're going to simplify. So if I have 6 times x divided by 2, that really reduces to just be 3x. Plus, if I have 1/3 times 6, that's 2. Equals, and then if I have 5x divided by 6 times 6, those 6's are going to cancel, and I'm going to be left with just a 5x. And so now I have a pretty basic equation that I'm solving for here. If I subtract 3x on both sides, I now have 2 equals 2x, and I divide both sides by 2, and I get that x equals 1. Now, just like with adding and subtracting, we do need to be careful with our rational equations that the solutions we get do not give us any undefined fractions. So we need to look for restrictions on the domain. Now, because this equation doesn't have any variables in any of those denominators, there are not going to be any restrictions. There's no possible way that I will have any of the denominators be 0. Obviously, you can see here my denominators are just 2, 3, and 6. So my solution to this problem is x equals 1. So here's our procedure for solving rational equations. We're going to factor all denominators completely. We're going to determine the least common denominator, multiply entire equations by that least common denominator. That's going to allow us to basically cancel out everything that was in the denominator, leaving us with just an equation that is no longer a rational equation. And then we'll solve that new polynomial doing our different methods, whether it's factoring, completing the square, whatever method that you feel like you can do to solve what we have left. We do need to check for those extraneous solutions in the original equation, specifically any of the solutions that might make our denominators, any of our denominators, 0. All right, so here's our next problem here. 5 divided by 3x minus 1 equals negative 2 times 3x squared plus 5x minus 2. So the first thing that we're going to do here is try and factor our denominators if possible. Nothing really to factor in the first denominator, but we want to try and factor the second denominator. And so I'm going to use my A times C, so 3 times negative 2 is negative 6. And I'm multiplying, trying to get two numbers to multiply to be negative 6, and it'll add up to be 5. In this case, it's going to be a positive 6 and a negative 1. And so if I split the middle term, I have 3x squared plus 6x minus 1x minus 2. no equal sign there. If I group, I get 3x as a GCF for the first two, and then x plus 2. GCF in the second pair would just be a -1, and that gives me x plus 2. And so if I rewrite my original equation here, I have 5 divided by 3x minus 1 equals -2 divided by, now in my factored form, I have 3x minus 1 times x plus 2. So I'm ready to identify what my least common denominator would be. So in the first equation, I have a binomial of 3x minus 1, so that needs to be part of my LCD. That same binomial occurs in the second equation, its denominator, so don't need to have it a second time, but it's already part of my LCD. But the other factor of x plus 2 also needs to be part of my LCD. So like my last problem, I'm going to take what I started with, my two fractions, and I'm going to multiply both by my LCD. Okay, so now that I have written that out, I'm going to be able to cancel because I'm multiplying. So this 3x minus 1 can be canceled with this 3x minus 1. And then here, both the 3x minus 1 and the x plus 2, each of those quantities can be simplified as well. And so what I am left with here is 5 times the quantity of x plus 2 equals -2. If I distribute, that gives me 5x plus 10 equals -2. I subtract 10 on both sides, giving me 5x equals -12. And then when I divide both sides by 5, I get a solution of -12/5. I do want to make sure that this is not an extraneous solution. What I'm most concerned with is, does this value of x ever make any of my denominators 0? If I go back to my factored forms that I had a 3x minus 1 and also an x plus 2. Now if I think about what values of x would make my denominator 0 and think about my restrictions, the value that would make 3x minus 1 equals 0 would be +1/3, so that's one restriction I have. And then the value that would make x plus 2 equals 0 is -2, so that's another restriction. Neither one of these restrictions is what my solution came out to be, so I'm confident that that value of x is a solution to this problem. Alright, another one here, a little bit longer. We want to think about factoring our denominators first. I'm going to just go ahead and factor and write that underneath what I already have for my denominator. So this first denominator has the greatest common factor of x, which leaves me then with x plus 2. So I'm going to just kind of cross that out and just be thinking about the factored form. Same thing in this next one, greatest common factor of x. If I take out x, that leaves me with x plus 1. Last one here, trying to factor that trinomial. It's going to be able to factor into two binomials, x plus 2 and x plus 1. So my least common denominator would be x, so that's part of our first denominator. What's also part of our first denominator is this quantity of x plus 2. In the second denominator that I have x times x plus 1. Since x is already covered in the LCD that I've written, I don't need to put it a second time, but that x plus 1 does need to be included because it wasn't there. Third denominator has the quantity of x plus 2 and the quantity of x plus 1. Both of those are already showing up in my LCD that I've written, so I don't need to write them a second time. Alright, so here's the kind of fun step, be fairly long here. We want to take what we originally started with and multiply each fraction by that LCD. So I get a little crowded here. We've got 2x plus 1 over x times x plus 2, and we're going to now multiply that by x times x plus 2 times x plus 1 minus the x plus 4 divided by x times x plus 1. That fraction is also going to be multiplied by the LCD of x times x plus 2 times x plus 1. And that's equal to 3 divided by x plus 2 times x plus 1. When we multiply by the LCD, there's what we have. A lot of stuff here. The nice thing is that a lot of it's going to cancel now. And when it cancels, I should be simplifying all my denominators down to just 1. So x's cancel, x plus 2's cancel. In the second part, x's cancel, and the x plus 1's cancel. Third part, x plus 2's cancel, and the x plus 1's cancel. Notice that nothing is left in the denominators except for basically a 1. So the equation I have left now is 2x plus 1 times x plus 1 minus x plus 4 times x plus 2, and that's equal to 3 times x. So a little distributing here, I have 2x squared plus 2x plus x plus 1 minus, and put this in a big parentheses here, x squared plus 2x plus 4x plus 8, and that's equal to 3x. So combining some like terms, I have 2x squared plus 3x plus 1 minus x squared minus 6x. So I've combined the 2x plus the 4x. That's 6x, but I'm subtracting it, so that's why I have a minus 6x and then a minus 8. All right. So what's happening here? Well, I have an equation where there's a 3x on this side and a 3x on this side, so those are going to just cancel. So, and then I've got 2x squared minus x squared, so now I've got x squared minus the 6x, and then I have a 1 minus 8, so that's going to be a minus 7. Since this 3x on the very right side of the equation canceled out with this other 3x, there's nothing left on the right side. So I have a quadratic that I need to solve for. I'm going to be able to factor that. And so my factors are x minus 7 and x plus 1. When I solve, I get x equals 7 and x equals negative 1. Looking back at my factored form, though, I need to consider what my restrictions might be. I can really look at my least common denominator, okay, because that's made up of all of the prime factors that were parts of the denominator. And so those restrictions were that x would not be able to be 0, negative 2, or negative 1. And what you'll notice here is that one of those restrictions is a solution that I came up with. And so it turns out that negative 1 is extraneous, leaving only x equals 7 as a solution. All right, so that is those are our examples on solving rational equations. What we will look at next is the absolute value, but that'll be on part 2 of the video.